hardwood, white pine, and you have just extensive tip-up mounds throughout the forest. You gotta think they're important.
Steve, I was just saying before we were last week in Washington, every foot is another. It's basically the whole floor has things growing over and stuff growing
One of the
on.
places we were walking, and tragic as it was, it's only 1,000 acres, but it's the largest unlogged tract in the entire Puget Sound.
In your drought, 95 degrees, 65 mile an hour winds, probably approaching, one end of the sort of extreme spectrum.
And in terms of what carries the fire, it's not that the big fuels that carry the fire. They may burn in small ways.
2/3 of this on the ground, and the rest is dead with no needles. Seems to me when the fire hits that.
But I think in these habitats, like what you were saying, or in a
If you're on the top
south-facing
of a dry
pea
slope or
pine.
something, it's different. We've got
Or
whitebark
if they're
pine at some
broadcast
of our
and not
sites
laying in the
that
forest.
got hit on the 1910 fire. Understand? I can still core them and find out what beetle killed them. But
Really?
you get onto wetter slopes, things rot faster.
Well, what do you think in terms of how these trees are going to remain standing? How long and how they're going to start falling out? Because they say, it's going to be like
5 years, everything on the
down,
ground.
down.
And then you'll get a fire and it'll burn all the soils and
So
they really don't do much
More
with
naturally.
controlling Doug fir beetles in the big trees. And the smaller Doug fir that are killed, they will go through bark. The lodgepole pine forest, whole different story. You can actually get the woodpeckers to control 90% of your mountain pine beetles over the winter. So they're your best friends. If you can keep your woodpeckers in those stands, you lick a lot of the pollen.
Well, we were just talking about in the
Not
winter,
here.
they're really active.
Yeah,
Is it,
that's their food.
so where do they go in the summer? Where are they feeding in the
They're
summer?
here, but they feed on easy food, bugs, things flying around. You don't have to dig for food, why bother?
So even the woodpeckers are...
They carry a blue stain fungus,
Oh, okay,
which is
yeah.
beneficial for them. It's a nutrient. And then they also have some of the
You
stuff
have
that
them
we
on
get-
you too, usually.
Yeah. Ooh. It's fine. It's
good to know.
Wash next time. So who knows? That could
In the College of Forestry and Conservation at the University of Montana, and I direct the Boley Center for People in Forests, which is a small center at the university focused on trying to provide a bridge between the communities of our state and region and the scientists. And I think that's one of the reasons I was asked to be the moderator tonight, because the purpose of our gathering is precisely to provide the public with some scientists from the university to talk about a number of issues related to the Middle East Fork Hazardous Fuel Project. I want to first begin by saying that this science panel presentation is sponsored by Friends of the Bitterroot and the Native Forest Network. And a goal of our presentation tonight is to provide some opportunity for some of the scientists who I'll be introducing in a moment to talk about their perspectives and to enable them to share their views with the public. I'm sure most of you are aware that tonight we're bringing together these folks to talk about some issues in forest ecology and explore the issue of forest health issues as it pertains to the Middle East Fork Hazardous Fuel Project, because it's been pretty controversial. And the goal is to have these folks who have their expertise in a variety of fields in forest ecology, but really don't have any vested interest or aren't working themselves personally on this project, but just to share their expertise with you about some of the issues. The issue of forest health and the proposed management actions to restore forest health, again, has been controversial. And so tonight is to let them bring some of their perspective, and then to have quite a bit of time, we hope, at the end for questions and answers from the audience. So we'll begin tonight by having two folks come up and talk about the alternatives in the draft EIS that have been proposed. Alternative 2 will be discussed by the U.S. Forest Service, and then Alternative 3 will be discussed by someone representing the Coalition of Local Conservation Organizations. Let me first introduce our panelists, but then I'll give you a little bit more background on each of them when they speak. So I have here tonight, the first one will be Tom DeLuca. You can just tell us. He is a soil scientist. He is a PhD and a professor of forest soils in the Department of Ecosystem and Conservation Sciences in the College of Forestry and Conservation at the UM. His research is focused on how fire and fire suppression influence biotic processes and physical characteristics of forest soils. Our next presenter will be Chris Frizzell. His specialty is in aquatic ecology. Chris Frizzell, also a PhD, is the Senior Staff Scientist at the Pacific Rivers Council and an affiliated faculty member at UM, and also at the Flathead Lake Biological Station. He is one of 8 authors of a review of post-fire logging. Our third presenter will be Peter Call. He is with the Montana State Extension Forestry, another PhD, and an associate professor of forest ecology, also in the College of Forestry and Conservation at UM. Dr. Culp has worked and published for 20 years on forest health-related issues in the inland northwest of the U.S. Our last presenter is Dr. Joe Fox, an entomologist and also a firefighter. He's earned his PhD in forest entomology from the University of California at Berkeley, where he was a Regents Fellow. His research is focused on bark beetles and exotic pathogens of conifers. He's 23 years of wildland firefighting experience, 19 years as a smoke jumper, and has also a law degree from the University of Idaho College of Law. And he's currently president of FUSEE, the Firefighters United for Safety, Ethics, and Ecology. So I've already told you the whole spiel on who these guys are. Okay, so let's begin tonight with the first person, and I'm not actually sure who exactly will be doing it, so please come on up, from the Forest Service to talk about Alternative 2. And I'm going to have to ask you to introduce yourself. Is it okay? Do you want to try and see?
Oh, this is fine. This is great.
Okay.
My name is Sandy Mack, and I work with the Forest Service. I'm the resource team lead for the Sula Ranger District and the West Fork Ranger District on the Bitterroot National Forest. I thank the Friends of the Bitterroot and the Native Forest Network for organizing this and for inviting me to speak with you real briefly about Alternative 2 of the Middle East Fork Hazardous Fuel Reduction Project. I'm going to talk real briefly about 4 different points. I want to explain to you a little bit about the purpose and the need for the Middle East Fork Project and the origin. I want to identify the 3 objectives that were established for this project. I also want to talk about how Alternative 2 was developed. And then the last point that I want to make and discuss is the measurement criteria that we looked at with all 3 alternatives. There's actually a 3rd alternative, which is the no action, to assess how well those alternatives meet our purpose and need. And I'll do that specifically related to the results of Alternative 2, as I've been asked to do. First, the origin and the need of the Middle East Fork Project. This project can really stem back to 2000, during the fires of 2000, when the Middle East Fork community, along with many other communities in the Bitterroot Valley, were evacuated from their homes. After that fire, the public decided that there was a need for a community wildland fire protection plan. And in 2002, newspaper advertisements announced the meeting to initiate that work in developing a collaborative community wildland fire protection plan. After multiple meetings, that work was completed in 2003. The Community Wildland Fire Protection Plan for the Bitterroot identified the Middle East Fork drainage as a high priority for fuel reduction because of the proximity of the homes to the forest. In 2003, the Forest Service initiated an interdisciplinary team to do an ecosystem analysis of the Middle East Fork area. And that analysis encompassed 25,800 acres. And there's several members of that interdisciplinary team here in the audience tonight. From that effort, it was identified that there's 84% of the analysis area, and I know that this isn't visible to everybody. We do have copies of summaries up here in the DEIS that this is in. But 84% of that area was determined to be outside of the historic fire regime. And that's represented by pink and yellow and red areas throughout here. This is the Middle East Fork River and where the private homes are. 84% of the area is outside of that natural historic range. And what that means is that they've missed some fire cycles that you would normally have have found or seen in that area. This resulted in sands that are denser than would be typically seen across the landscape in those areas. The plants and the animals that are associated with those systems and evolved with those systems then are living, or then are faced with a different structure, composition, and function in those habitats. The result is that the probability of an uncharacteristically severe fire in those areas is higher than in areas where the fire regime class is lower or more closely related to the natural system. From the watershed assessment that the Forest Service did, they had a public meeting to present this information and to initiate work on a proposed action to treat vegetatively the fuels in this area. There was, again, a newspaper announcement. There was a letter sent to over 120 individuals. I know that one thing that we regret is that the Native Forest Network didn't get a personal invitation to that first meeting. The Friends of the Bitterroot did. Some other interested parties did. With that work, there were 3 objectives that are identified for the Middle East Fork project. And that was to reduce wildland fire threats to the Middle East Fork community. It's the first objective. The second objective was to restore fire-adapted ecosystems in the Middle East Fork landscape. And the third objective was to restore the stands that were infested with Douglas fir bark beetle and to treat stands that were at imminent risk of spread of the bark beetle. And the purpose was to restore the stand structure and function in those areas. The development of Alternative 2, which is the proposed action, is a little different than in a lot of projects in the development of an alternative. There's a lot of effort and energy put up front to develop an action alternative that best met those 3 objectives while still meeting the interests of the community, the interests of interested parties that were involved, and the resource specialists that were involved. So a lot of energy was put into one alternative to develop that, to minimize impacts to other resources while still meeting those 3 objectives. Initially, there was like 9,200 acres identified of potential treatments to reduce fuels in the Middle East Fork area. Through that iterative process of public meetings and interdisciplinary work, that was honed down to about 6,800 acres of treatment that is proposed in the draft environmental impact statement for the Middle East Fork project for Alternative 2. The treatment's focused on what would be left on the landscape after the treatment. The intention is to mimic the composition and structure that would be found across the landscape if fire was allowed to be the disturbing factor that it would naturally be. This is described really well in Steve Arnold and Carl Fiedler's new book, Mimicking Nature's Fire. In all of the treatments in Alternative 2, in all the treatments, the largest, healthiest live trees will be left on site. And this is a very important point. I think there's been some misunderstanding or misinformation about this. And I think it may have stemmed from a field trip we had, which in a particular unit, we were talking about what the treatments might be in that stand. And we said that there would be 4 to 12 snags in that particular unit, based on the habitat type that was there, that would be left after the treatment. But that was specifically tracked to snags. Again, the largest life, healthiest trees will be left in all units. In stands that have had so much Douglas fir bark beetle mortality, where there's a need for us to regenerate those stands, need to do some planting or do some things to regenerate, there'll be between 40 and 60 square feet of basal area remaining on those sites. In other areas, there'll be between 80 and 120 square foot of basal area of live trees left remaining in the area. And again, the focus really was on what are we leaving in the area and how are we doing that in a way that mimics what would naturally occur with repetition of fire intervals. To assess how well the 3 alternatives met our purpose and need, we looked at measurement criteria, and again, you can't really see this. It is in the document, we'd love to show you. But for the first criteria to reduce the fire impact or reduce the risk from fire to the Middle East Fork community, there were 4 criteria that were looked at. The first was, after the treatments, how well or how many acres on the landscape were shifted toward a fire regime condition class that would be more natural, moving it from a fire regime condition class that's outside of the range of historic regime towards one that's within. And on the middle, alternative 2, there's approximately 5,000 acres that's moved towards a better fire regime condition class. Within the wildland urban interface, alternative 2 would reduce flame lengths on 860 acres. It would reduce the rate of spread on 550 acres, and it would reduce the crowning risk, again within the wildland urban interface, to 820 acres. I should mention that the wildland urban interface is a delineation that was made by fire specialists looking at the topography, looking at the existing fuel types, looking at the condition of those fuel types, and about fire behavior in that area to delineate what that wildland urban interface delineation would be. So look at how the alternatives met the second 2 objectives of restoring fire-adapted ecosystems and treating the Douglas fir bark beetle stands and the imminent risk of stands that hadn't yet been infested. There were 7 criteria that were looked at. Alternative 2 will plant approximately 860 acres of ponderosa pine. Our information, our data shows that there's approximately somewhere around 50% less ponderosa pine in the Middle East Fork area currently than there has been historically. So it's a component that is improved by alternative 2 in this case. Improving structure and function on 6,400 acres. Reducing the Douglas fir bark beetle hazard on approximately over 3,000 acres in alternative 2. Alternative 2 reduces the mistletoe in 1,300 acres. It increases the resilience to pine beetle on approximately 2,600 acres. It actually regenerates 1,000 acres. And it reduces fuels, both ladder fuels, ground fuels, and stand density on 6,400 acres. Also identified in the Middle East Fork area are some ecosystem components and forest resources that are at risk. And those ecosystem components are, again, compared with all 3 alternatives to see how the treatments would help protect or reduce the risk to those ecosystem components. One of them, which I just mentioned, was ponderosa pine, and alternative 2 would reduce the risk to 4,400 acres of ponderosa pine, or help protect that many acres of existing ponderosa pine. It would treat stands and help move again towards a structure and composition that you would expect to find in a fire-adapted ecosystem on about 4,600 acres of warm, dry, and moderately warm, dry habitat types. It would protect about 3,000 acres of mature Douglas fir that's over 14 inches, and the cover that those live trees actually provide. It would recover the timber resource value on 3,800 acres approximately, and it would protect the productivity of suitable lands on about 1,400 acres within that Middle East Fork area. And finally, it would rehabilitate or move towards rehabilitation about 1,000 acres of grasslands in that area. I'd like to let everyone know that the comment period for the draft environmental impact statement is currently open. That has been extended at the request of the Friends of the Bitterroot and the Native Forest Network to June 13th. It's not as long an extension as was requested, but we hope that it gives people an opportunity to study the information in the draft environmental impact statement, give us comments. There's comments forms up here, and I know that the community is very anxious to implement this work, and our plan is to have a decision this fall and be able to start implementation this fall or winter. So at the end, I'm happy to answer any questions, and thanks again.
Alternative 3 will be discussed now. I'll let you introduce yourself as well.
Thanks. My name's Larry Campbell, and I work with Friends of the Bitterroot, and I appreciate you all being here tonight. We try to bring on scientists on occasion after the 2000 fires. And then, for example, last week, Jack Cohen did a presentation. I'll give you a little background on Alternative 3. I guess our primary objectives were a few. One was to present a constructive alternative that involved active forest management in this area. We decided to sort of keep our eye on the ball and focus on home and community protection, which was the stated priorities during the fires of 2000 that was followed during that fiasco and firefighting there. They focused on protecting homes and the community. Our alternative does that also. We also wanted to have an alternative that represented bona fide restoration, which we feel is primarily directed at removing human-caused obstacles to natural recovery. We believe that natural recovery is I guess you could say, exquisitely site-specific and infinitely adaptive. There's really, in our view, nothing that beats natural recovery, but there are things on the landscape that inhibit it. And also, one of our objectives was to follow the best science and law in forming our alternative. We called it the Community Protection Local Economy Alternative, which I think really describes what our priorities were. It was developed by not only Friends of the Bitterroot and Native Forest Network, but also the Ecology Center and the National Forest Protection Alliance. Initially, the way we looked at it was we sort of looked at the landscape in 3 zones. One, the home ignition zone, which was described in Jack Cohen's presentation last week very well. As a matter of fact, he probably invented that term. He stands alone in his expertise on how to deal with that. That zone lies within about 40 meters of the home. The next zone out is the community protection zone, and based on the best available science, that involves an area of about 400 meters out from the home. And then the third zone is a zone that's beyond that community protection zone that would extend out to the project area boundary. And in that zone, what we looked at was watershed and forest restoration, primarily dealing with road restoration, because roads are commonly an inhibitor to natural recovery, and also recognizing that there are effects from whatever 80 years of indiscriminate fire suppression that's resulted in overdense understory, dug fir generally growing up under the ponderosa pine. We advocated removing ladder fuels out from under what we call legacy trees, which are the very large trees that were there far before fire suppression began and are a threatened resource on the forest, and also would involve some pruning, possibly, and raking of duff that's accumulated through lack of ground fires over the years. We then presented our alternative to, well, I think I should mention that one take-home message is that you may read and just hear through the grapevine that conservationists are just opposed to active management. Well, you'll notice that our alternative involves active management, active forest management. Also, our alternative indicates our concern for humans' health and welfare, homes, human lives. The community protection zone is all about protecting human lives, firefighters and people trying to escape the fire, driving down East Fork Highway or whatever. And also, you might note that there is some advocacy of commercial logging contained in that alternative. We offered the Community Protection Local Economy alternative to the Forest Service, and they accepted it for analysis in the Middle East Fork DEIS, which we're grateful for. We were disappointed that it eventually morphed into alternative 3, which eliminated the work around homes for probably good reason, that that's primarily private property. We were hoping to have you know, a Forest Service sort of inspired group that would go around to homes, assess what could be done to protect that home, and not necessarily do the work, but at least do an analysis. That was eliminated from alternative 3. And also the work that we consider bona fide restoration, the road restoration work was eliminated, and also the work beyond the community protection zone to protect these legacy trees out through the project area was largely eliminated, not entirely. And the watershed restoration work was entirely eliminated from this healthy forest restoration project. So the way that it sort of boiled down to alternative 3 involves the way it's presented in the DEIS primarily involves whatever the work within the community protection zone, that is the 400 meters around homes that does not lie on private property, would be treated according to our suggestion, our proposal. We feel that work is actually probably more effective than what's presented in alternative 2, primarily because it involves pruning the lower branches, and alternative 2 does not. The science basically supports our contention that the work presented in alternative 3 that would protect the community protection zone is adequate to do, just as it says, protect the community. And the advantages of it is we believe it's not only more effective for the reason I mentioned, but also more efficient because that's what it focuses on. The work, the money left over, alternative 3 would cost taxpayers approximately $500,000. Did I say alternative 3? Alternative 3 would cost taxpayers about $500,000. Alternative 2 would cost taxpayers about $1.5 million. And in our view, that means that you could do this scientifically proven effective community protection work in 2 more communities similar to the Middle East Fork. And while alternative 2 would be out logging what we call the backcountry, that is in an area that has little to nothing to do with protecting the community, with our alternative, they could be, you name it, up the West Fork, 2 other communities here in the Bitterroot Valley there that need community protection work that will be waiting through who knows how many more fire seasons before that work can be done. That's why we consider alternative 3 to be more efficient than alternative 2 in protecting the highest priorities, which is home protection and community protection. We also advocate beyond the community protection zone to thin the plantations. The plantations are sort of a human-caused remnant of out there in the forest that they do need thinning. They're somewhat artificial, and they need some work. So we propose to do thinning in plantations, as well as along with the protecting the legacy trees beyond the community protection zone. That is, in a nutshell, what alternative 3 is about. I'll just leave it to people you can read in DEIS how that spins out in terms of the analysis that the Forest Service did out in the forest in terms of how much commercial logging would result, how many acres of the forest is returned to a fire-adapted ecosystem, etc. And I'd be happy to answer questions at the end if you like. Thank you.
So now we'll turn to our 4 panelists. Again, these are all PhD talk within their field on issues related to the Middle East Park Hazardous Fuel Project. Let's begin now with Tom DeLuca, our soil scientist.
Should I step up? Or?
You can speak wherever you feel most comfortable.
I'll stand up.
All right.
Thanks for the introduction, Jill. And I just wanted to state I didn't prepare comments for tonight, or notes or anything. My intent was to come down to be able to answer questions for you all. And so with that in mind, I'm just going to give a little background on myself and my history, both in the Bitterroot as well as in soils research at the University of Montana as a whole, and leave it open. My intent is as a unbiased third party, as a soil scientist, to answer questions. And so I hope that some of what has come up this afternoon will stimulate questions, or over the last several months has stimulated questions that you may have about soils or impacts of timber harvest or fire to soil. And I'll do my best to answer those as a soil scientist and as a professor at the University of Montana. Just to give a little background on myself, I have 3 degrees in soil science. Yes, you can get a degree in dirt, which is a question that comes up pretty often. As a matter of fact, Brian Gumbel once fell out of his chair laughing that somebody actually had a PhD in dirt. And I have a PhD from Iowa State University in soils, specifically studying microorganisms in soil and their activity. It sounds pretty crazy, but it has to do with the cycling of nutrients and the availability of nutrients to different forest or plant communities. I have a master's degree in soil science from Montana State University. That's right, I'm a cat, but don't hold it against me. Kelsey still does to this day. I have a master's from MSU in soils, and then I have a bachelor's from the University of Wisconsin also in soils with an emphasis in chemistry. Over the last 11 years, I've been a professor here at the University of Montana, working up from an assistant professor to now, and studying soils in a number of different perspectives. I've done research actually on the terrace stands down here in the neighborhood, and I've had a number of studies dealing with fire effects in soils, both restoration treatments with regard to use of prescribed fire and timber harvest to restore stands to a sort of historic stand structure. I've also done a lot of work on wildfires, both in the Bitterroot and the surrounding area, looking at what are the impacts of fire on soil and soil processes, and both physical impacts as well as biological and nutrient cycling impacts. During that time, I've learned a lot and have asked a lot of questions and have come up with probably more questions than answers. As you'd imagine, these things are incredibly complex, and there's no single or simple answer to most of the questions that we're able to raise. But one of the things that has come up over the last years is, okay, we have a pretty good idea of what happens when we reintroduce fire as a prescribed fire as a tool, or if we have wildfire reintroduced to the landscape. But some of the questions that we have less understanding of is what happens when we don't have fire? What's the effect of the exclusion of fire from an ecosystem that has been adapted to fire evolved with fire for centuries and centuries, for as long as time has been. And so we've done a lot of studies on those. We've chronosequence studies in the Bitterroot, as well as recent studies where we've gone into the Selway Bitterroot and Frank Church Wilderness areas, trying to look at what's a historic fire-maintained forest really look like, and what are the soils? How do they operate? How do the processes function in those soils compared to managed timber stands? And it's been very eye-opening, actually, and I'd be happy to talk about that. Some of my work drew me over to Northern Europe, where there are stands that have had fire exclusion for over 400 years. And because of stand management and land management, as well as active fire suppression. And so I've been working in northern Sweden on fire ecology there as well. And you might think Sweden doesn't sound like a very logical place to do fire ecology work. Do they even have fires in northern Sweden? It sounds like a pretty wet place. But interior Sweden is surprisingly dry and surprisingly similar in terms of stand structure and stand characteristics of Scots pine stands to our ponderosa pine ecosystems here. just a longer fire return interval and differences in forest stand structure and soil morphology as well as. But still a fire-maintained ecosystem, and so we've learned an awful lot by doing work over there as well, and it brought a lot of my experience from that ecosystem back and applied it here in Ponderosa Pine as well. I'm not going to bore you with a lengthy, I won't go on any further here, except to say that I feel as though I have a fairly solid understanding of the influence of fire and starting to get some grip on the effects of fire exclusion on forest soil processes. I've also done some work with timber harvest and stand management influences on soil physical and biotic processes, and I'm happy to address questions, well, I'll try to address questions from that perspective as well. So once again, I'm here as a unbiased third party. I'm here to answer questions, not to give you answers that you haven't asked for. So I'll leave it at that and leave it to you to come up with difficult questions that I probably can't answer, but it will do my best to address. Okay.
The next member of our panel is Chris Brazell, and he's our aquatic ecologist.
I'll take a little different approach from Tom, but I'm going to do a little bit of fire ecology 101 introduction, just to provide some context for questions that will hopefully come up later. I have a PhD in fisheries science, but my area of expertise has always been in land management and the interface between land management and freshwater habitat conditions for fishes and other critters that live in streams. And I grew up in Missoula, grew up pretty much spending a lot of my time in the Bitterroot, and worked for the Bitterroot Forest for a couple of summers, including one summer doing a lot of thinning, pre-commercial thinning and fuels treatment work. I've worked on some of the ground that burned in the 2000 fires, and so I have sort of that perspective on what's going on in the Bitterroot, as well as the scientific perspective that I bring from my research experience. And I want to share just a few of the principles that I bring to this question about what do we do about managing forests. We have some issues with regard to fire suppression. We have issues with regard to fires as they are bound to happen on this landscape. We have issues that relate to historical management of timber on the landscape, and in particular, the issue that has the most consequence for fish and needs to be the target for so-called restoration programs on the part of the federal agencies is the issue of roads. Roads are the biggest problem for water quality and for native fish and other fishes in the Bitterroot National Forest. I think that's pretty clear, and that's said in the environmental impact statement. Yet we're looking at another project in which it does not target roads really for the level of restoration and upgrades, and in some cases decommissioning that are necessary in order to get real restoration of water quality of fish in this forest. Our native fishes in these smaller streams in the inland west and western Montana are basically fire-adapted species. And if you fish the Bitterroot streams post-fire, 2000 fire, you probably noticed this. I certainly did. And it's been confirmed with research now that basically Westlaw cutthroat have shown in many streams that were burned in the 2000 fire, they've actually experienced a little bit of an increase in their populations. They appear to have benefited in various ways from the fire impacts. Eastern brook trout, which is an introduced species in these streams and has a lot of harmful interactions with the native species, has actually suffered in many streams, and that appears to have benefited the native fish species. Bull trout also have held their own pretty well in streams that were fire impacted. So it's not only the forests that are fire-adapted ecosystems in our region, it's the streams themselves and the fish that live in them. There's a big difference between how fire disturbances affect these ecosystems and how the activities that we've put on this landscape in the form of logging, compaction of soils, and roads affects those ecosystems. Fire tends to have a very pulse disturbance. Yes, there is a sediment increase associated with wildfire. In some cases, it's fairly large. You have landslides that occur after intense wildfire removes vegetation. In other cases, it's a fairly small increase, but it's generally, in all those cases, it's usually a fairly short-lived pulse. and it works its way through the system fairly quickly. And that's as opposed to these effects that arise from the persistent results of soil compaction and roads on the landscape, which have persistent chronic effects. They occur every year, every time there's a rain. They essentially press that ecosystem down, and there's no opportunity for recovery from the impact of those degrading processes on the water quality and fish habitat. So there's a big difference between the kinds of disturbance we're talking about, and the major trade-off that's at issue with regard to fish and freshwater water quality conditions in these streams is that along with the logging that's being proposed in these alternatives necessarily comes reliance on the road system, and there also comes soil compaction, which is above and beyond the historical soil compaction that's occurred in this area and that we're still living with. So those are the issues that need to be dealt with and are on the table, and I won't give you a roadmap for how they should be resolved, but I wanted everybody to be thinking about those things for now. Thanks.
Our third presenter is Peter Pope. He's our state extension forester.
Well, I wasn't quite sure what format would be used here, so I actually came prepared even with a little bit of PowerPoint slide presentation. And I'm sure there's not time to really go through all of it. But perhaps I'll use a few as visual aids. As Jill mentioned, I'm actually at Montana State University professor I'm a forestry extension specialist. I'm also an adjunct forest ecology professor at the University of Montana, where I'm housed cooperatively. I've been involved with these types of issues, as was mentioned earlier, for almost 20 years. In 1994, I was doing research on the Bitterroot National Forest, looking at forest health-related issues, bugs, insects, diseases, and how those related to tree physiology on that forest. Now, some of you may recall, in 1994, many acres in the Boise burned up in rather large landscape-level fires. And my sampling season started early, so I started in low-elevation forests, and I worked my way to high-elevation forests. And as I left one area that I had assessed and put in measurement plots and done ecological monitoring on, they would burn up. And as I moved to the next ones and was finished there, those would burn up. Now, luckily, nobody ever drew a correlation between the fires and myself, otherwise they might have been looking at me rather hard. But that really got me looking at the role of fire in the entire role of forest processes and succession. And so I put together a few visual aids, and just to run through these things in a real quick nutshell, the ecosystems that we're dealing with on this proposed project, and I've had the opportunity to get out on the land several times to look at them, are really a two-age structure forest. We have a smattering of, and this is not the forest, this is just for demonstration. I have some pictures of the actual scenario. We have a smattering and a groupie mixture of 300 to 500-year-old ponderosa pines on the Middle East Fork proposed areas, and that is surrounded largely by dense, approximately 200-year-old Douglas fir. It's really a two-age structure, though the canopies and the size is the same. Now, as a quick review, many of our forests were maintained as open ponderosa pine. This happens to be prim meadow, a remnant area. Over time, what we see all across the inland Northwest is that shade-tolerant and less fire-tolerant species have invaded. You've all seen this type of scenario occur. Let my computer catch up with me. And with this also comes other types of concerns, the ones that I was looking at pretty hard on the Boise and have been looking at in Montana ever since. And this process is called succession, where once we've had an opening, pioneer tree species, typically ponderosa pine, will colonize the site because of specific physiological adaptations to deal with the stresses of an open site. Over time, without fire, my screen's not big enough, shade-tolerant species will regenerate underneath these pioneer species, and without any disturbance, eventually, they may actually dominate the site. Now, the phase in time on much of the proposed Middle East Fork project is right about in this space right here, where we have dense, large Douglas fir with a few large, older ponderosa pines on the site. And And the problem that occurs with all of this is, as this process occurs, you get more leaf area from trees on the area, and more leaf area equates to more rainfall and snowfall interception, plus more water pulled out of the ground through transpiration and put back into the atmosphere. So these stands, as their leaf area increases, essentially the soil water balance and the water stress to the stands increases. Now, drought stress, and this is one view of some of the project area, the Middle East Fork. What we have is leftovers from the 2000 fires up in here, and this is area that the fire didn't move into. This is a younger lodgepole pine stand, and I actually haven't been into that. I don't know if it's a result of a past fire or past harvesting. When these stands start to get stressed like this due to drought stress, trees physiologically respond in two ways. One is to maintain water in their system. They increase the sugar content in their needles and in their vascular structure. The sugar content grabs hold of the water and prevents the tree from losing it. The other thing is, because they have that sugar is being allocated towards that, they have less sugar available for secondary defenses. And if they're drought stressed, they also have less water to push pitch, which is a primary defense mechanism. So the trees are less able to defend themselves, but on the other hand are much more nutritious and much more attractive to beetles because of the high carbohydrate, sugar, starch content that they put into their cells in order to conserve water. And that makes them highly susceptible to insect and disease infestation. Now, this proposed treatment area has a lot of past history to it. You can see the old terracing there. Many of the proposed treatment areas are in these previously unharvested areas, and you can see some of the flagging coloring trees that are in there. When you get into the stands, they're beautiful stands to walk through at this point in time. They're cathedral. These Douglas fir are around 200 years old, and again in between some real large ponderosa pines that are anywhere from 300 to 500 years old. So they're quite striking. The problem is that there's an exceptionally high mortality rate in them. And, that's just what's happening, and we've been seeing this happen on and off for the last 15 years, all through Idaho and Montana. The problem is that once those trees die, eventually they fall over, and you end up with woody debris on the ground. And woody debris leads to certain fire risks. Let me go through this. I thought I turned all this off. Sorry about that. And with fire risk, we not only look at the specific site, but what are the trends? And this is some research done by David Peterson from the Pacific Northwest Research Station. We've all seen these types of graphs that historically, at the turn of the century, we had a lot of areas that burned, and fire suppression, supposedly, no fires, and then recently a lot of acres burned. And what David Peterson and many others have done is they have looked at the effect of climate. And we have climatic fluctuations, Pacific decadal oscillations, typically what it's called. And what he's found is that these burn times tend to correlate very well with hot, dry periods. And we, of course, were very successful suppressing fires during cool, wet periods in our climate. So yeah, fires are largely climate-driven, and perhaps we give ourselves a little too much credit for suppressing all of this. Now, if we look at the bigger picture of climatic fluctuation, and this is one of the concerns as an ecologist of these forests, how do they respond? This graph actually goes back from a variety of different research projects, and I'll just scan this through here, all the way back to 1000 AD. Here's where we currently are, global warming or a significant warming trend. But what you also see is that our climate in here, and this represents the entire northern hemisphere, we've had tremendous past fluctuations. Nature isn't a steady, static type of thing where when we talk about restoration practices, we leave it alone, it's always going to be this way. We have huge climatic influences, at least in the last 1,000 years. And actually, if we go back 2,000 years, and this is off of some lake sediment data, this is the average from 2,000 years. Here's since 1200 AD, we've been cooler and wetter than average. And actually from 0 AD to 1200 AD, we had a very, very long, warm, dry period. So these climate fluctuations, people ask, well, how long is this drought going to last? Well, It can last 10 years, it could last 10,000 years, for all we know. So the point is that we have these tremendous climatic fluctuations and nature responds. It responds largely with fire. I just want to make the point with fire, we have intensity measurements. We talk about restoring fire, active crown fires, passive crown fires, consuming trees, and then we have surface fires. Those that are lethal to trees and those that are non-lethal to trees. My research as an ecologist has actually looked at the effect of fire, or severity. And those are the impacts to trees. Are trees killed? The impacts to surface vegetation. What happens to the ground vegetation? The soil surface, litter layer, humus layers, and then finally what happens to the mineral soil. And I have a graduate student who's just finishing up some research who's monitored and studied the effects of fire, the 2,000 fires in the Bitterroot, both up Laird Creek and on the Sewell State Forest. And this is some of the organic debris that actually Tom has worked with. And you can see this is in a system that hasn't had fire for about 400 years. And you have, in this case, 3 inches of organic matter with a lot of roots in that and underneath the mineral soil. And I bring that into place because when we talk about fire severity impacts, we have different effects. This is a light surface fire where much of that organic layer was left intact. And you can see this is in the spring following the fire, you're getting a lot of resprouting after that fire. This is a fire where a lot of the organic material was burned, but the humus layer was left intact. This is a fire where the entire organic layer was burned off and the mineral soil itself was impacted by the fire. And I bring that up, here's some of the most severe scenarios of fire that we saw. This is 1 year after the 2,000 fires up Laird Creek. You can see just barely on the left, areas that had less impact are starting to green up. This site, even now at 5 years, only has about 40% vegetative cover on it. This is some of the real severe fire impacts, and Jill's telling me to be quiet.
No, I'm just telling you to...
Or sit down. Okay.
Just give me more.
This is the basic area. Thanks, Jill. On the other hand, this is an area that also burned in 2000 that had been thinned and harvested and fuels reduced on it. And you see the surface vegetative recovery on these types of fires. And I'm not advocating one or the other. It's just with different fire severities, we get different impacts that occur. Now, factors that affect recovery, what was originally there, what's the fuel load, the type of fire, and what happens after the fire occurs, the weather pattern that happens after the fire. To give you an idea, this is a dense stand where there wasn't much understory vegetation. This is 1 year after recovery. This is a more open stand where there was more vegetation prior to the fire, less organic layer, 1 year after recovery. This is an area where there was an enormous fuel loading left by management. It was harvested and a lot of debris was left. It burned very severely. This is what it looks like 1 year later. This is what it looks like 4 years later. Wherever there was very severe fire impact, we see very slow recovery rates. And in addition, we see that noxious weeds have tripled their cover on these most severely burned sites. So that's a concern. This is a site that had no management on it, but a very thick organic layer. 1 year after fire, 4 years after fire. And what we have here is about 90% occupancy by weeds on it. So this is a concern. Conditions have changed. Then there are secondary impacts, large-scale watershed impacts, because the ground doesn't absorb water as well. What I call tertiary impacts. This is up Laird Creek drainage. 1 year after the fire, 3 years after the fire. Douglas fir beetle likes these type of stress stands and has gone ballistic in their epidemic proportions. So when discussing and thinking about how we want to see these forests survive when we see climatic fluctuations occurring, fires a factor or a result of those climatic fluctuations, one of my concerns as an ecologist on these forests is how are we protecting our genetic resource out there, the big trees that are left there. If we have high fuel loading and a fire, we're going to lose a lot of those trees. If we thin some of those areas, remove some of the debris, we can protect those trees, but there may be other consequences involved. So those are some of the questions and some of the issues that I've dealt with. And I'll be happy to answer more.
Great, excellent, thank you. Dr. Joe Fox, and he is our entomologist and firefighter.
Hi, I'm Joe Fox. How many firefighters are there out in the audience? Well, you survived these beetle-killed fuel deposits, I see, and you're here. So we sort of know that you can, on certain conditions, you can walk across a lot of fuel and it won't be burning very hot. It does depend a lot on the climatic conditions. So fuel buildup's not always necessarily a disaster, and firefighters have seen it and know that. But I'll get to fuels in just a minute. I'm an entomologist by training, and at Berkeley, and I studied the interactions of some pathogenic fungus to trees with bark beetles, and throughout working over 23 years as a firefighter, I saw some of its effects out in the field. I want to go to a point. Forest Service, in their report, they don't really directly say that they're trying to manipulate insect populations, but there sure is a lot of impression that that's what they're going to help do. And this process is called direct control. And it gets sort of misinterpreted or translated to the public that they're going to go and do something about the insects out there. And they can't. Direct control is discredited. It's never worked. They've been trying it since the 1930s, 1950s, and they started with convicts going out in the woods and cutting trees and pouring oil over it. It was kind of a medieval siege mentality. And then when the pesticides came in, DDT was used, and then Durstben and everything else, and they poured that on them. Didn't stop them. And then during the Vietnam era, when plastic explosives came in, they went out and they started dynamiting the trees. That didn't work either. Direct control just doesn't work, and I don't think you'll find scientists supporting that concept. So this is not about removing the beetle population. I mean, it doesn't work. It can work in maybe some limited areas, urban situations maybe. Jury's still out on that, I think. But it's not going to be part of what they're doing. And they don't really say that, but the Forest Service hasn't really gone out of their way to explain that that's not what they're doing. When they do these treatments outside, there's another factor. I mean, even if pouring oil or pesticide, or if they've got a lot of dynamite out there, and they could do something in some of these zones, they're not going to treat the whole forest. So there's a reservoir of beetles that are always going to be flying into these situations. And in their treatments, it's just not going to have much of a effect. Intuitively, you know this. You can't chop down the tree and get it to the mill before those beetles fly out of the log truck and onto other trees. It's just not going to work. So direct control, one of my points, is not going to work, and that's not part of this project. So it's not an insect control thing that's going on here. Okay, how about thinning to improve stand vigor? And there's a lot of reasons to thin, and I advocate this, and I think most groups do. It's a good thing to do. Thin the thin, make trees vigorous. That might be something to do. But the truth is that there's mixed evidence that this works for beetle control too, making a tree more vigorous, more able to withstand beetle attack, because once again you get these huge populations, get mass attack, the strongest tree out there, even one that could survive dynamite would probably get taken out by an epidemic. So there's mixed evidence on whether this is going to work for stand improvement. Protection from beetles may not work. Okay, I guess because time's going on, I'm going to move to this fuel concepts. And if you have any more questions about beetles, we'll talk about it. The big issue is recovering the value of the tree, and that's what it's about. It's not beetle control. under fuels, being a firefighter and working out in the woods, getting sent on fires, walking across 6 feet of fuel to put out that little spot somewhere. You get it in your head that fires are a mosaic. And I fly to fires. When I was working, I'm 5 years retired from being a smoke jumper. But I've flown some of the big fires that were around McCall. And I've been, I was one of the last jumpers to jump the Yellowstone, and I've gone back and visited, flown over it a lot. And when you're up in the air, you know it's a mosaic, you feel it, you see it. And the fuel loading has sometimes very little to do with this. That's not to say that absolutely nothing, but you can find places where there's a huge fuel buildup and severity. You can walk into places where there's huge fuel buildup and low severity. It's more of a wind-driven, localized conditions. That day was wet and moist. It didn't burn with great severity. So what I'm saying about this is you're just taking a risk in whatever you do. There's always fuel on the ground. A light fuel on a very hot day with 5% humidity, you're going to probably get a crown fire. There's just no stopping it. But if the time the fire comes in, you could, prescribe fires. They have these prescriptions, and there's a reason for that. They want the micro conditions to deliver just the amount of fuel that they want to burn off. Okay. Also, from my own experience flying over, seeing these mosaic patterns, there's quite a body of literature that also supports this, that this fuel buildup's not going to exactly determine what sort of fire you're going to get. It's other conditions. Wilderness reports, Biscuit Fire, which is where I live now in Eugene, burnt into a fire. I happened to be stranded in the middle of in 1987, and fire all around me. Silver Fire. But it got into that, and it did the same sort of thing. Some places it burned severe with all that reburn potential of the fuel laid down. Some places it just leapt across the surface of it. There's a report that's coming out, getting the Forest Service, the BLM, the tribes, the state. It's called the Quadrennial Fires Fuels Review Report, something like that. And you'll be seeing more of the information about this. And what they're talking about is, let's just protect areas that we want to protect. Communities, maybe there's some special places in forests, things like that. You use ignition opportunities to let the forest return itself to its ecosystem, fire-adapted ecosystem. Part of this is going to be making fire-adapted communities. And they're talking about more than just fire-wise, go to the website and rake the leaves off your roof and things like this. This is more of a commitment to make the immediate area around you, sort of in a Cohen fashion, more adapted to fire. Let this fire trickle through. It's a fire permeable area. It comes through. You're not damaged. Your property's not damaged. The reason for this is they're saying there's just not enough money to treat everything. What the Forest Service is advocating here, I think, is sort of a misuse of money in some ways. They could protect more communities by not logging so far away. Keep it within the vicinity. Protect these communities. But use ignition opportunities. They are in some sort of prescription to do the work that they want to do. Reduce fuel loading. Things like that. You can, it's going to be a matter of suppressing when you have to, but use the opportunity to get a lot of acreage burns. And all that's in the quadrennial report.
This is the part, I think, which is the real heart of our reason to be here tonight. Please, if you want to address your question to any one of the panelists, please indicate, or if it's a general question, that's fine. I just ask that you keep your question or even a comment just short and to the point. So who would like to start? Please.
I thank you and the panelists. Great experience. I thank the sponsoring groups. But other than the presentation on aquatic impacts and the last presentation, I'd like to use names if I were just a little quicker in my mental process. We have sort of walked around what we should do on the Middle East forest. We have this landscape that was a classic example of abuse in the 70s, late 60s, when we had terracing, clear cuts, some of the worst clear cuts in the United States. So you climb out on the ridge today and you see the tragedy of that period in national forest management. And while we all say that was a sad period, we're beyond that. Here we have now some remnants, grandfathered trees in pockets, a mile or two from the community, which is down on the river. And we all agree we will protect it with every means possible, thinning any good practices. But what do we do to save some of that remnant stand? What impacts on soil do we see with some more eroding, some more silvicultural practices up on the slopes? Where do you individually stand on the Middle Fork? What do you see as a way through the controversy that prevails today? Individually, if you could answer that, it would give us direction. All of us would like to be liked, but we find a real controversy here. And it's a history of land depletion, mistakes. We've all been a part of the mistakes. How do we draw people together with a line and a direction that will give us some good, harmonious management? I'd like you to tell me. And each one of you.
Well, that's the question, and I'll give you each 2 minutes. Let's just go down the line.
Me?
Sure, we'll just go straight down the line.
It's community protection, both address that and sort of equal looking at that. I think the alternative 2 plan here sort of says, well, we're going to do this, but it's sort of extracting out some trees and things like that. They're going to select the trees that are going to be taken out, and if you leave it alone, the beetles will select it. But it's a lot of money spent on doing this project. Alternative 3 has part of they would go out, and as you called them, legacy trees. In California, in the Tahoe Basin, they call this monarch trees, and it's kind of the same concept. You thin away the stuff around it and rake it out, and put a little bit of personal attention to those trees. And I think that's the way to go, because reducing the fuel load and things like that, those are all well and good, but it might have little to do with what happens when a fire comes. Okay?
I think community protection being a given, I would characterize there being sort of 3 residual issues, hot issues. Beetles, and my take on beetles is that I've seen this forest type in other places in previous decades go through beetle kill, same beetles, same kinds of stands, and basically it's a fairly transient episode of thinning. You lose a certain percentage of the stand, and then within about 6 to 8 years there's complete canopy closure. After that, you essentially have a stand that looks about like it did 10 years previous, only there's snags in the stand that didn't happen there before, which is a pretty darn good thing for certain wildlife species. So I think the beetle thing it's easy to get manic about it, but it's the wrong thing to do to get manic about it. It's a climatically driven episode. Wherever you don't have fire and you have prolonged drought, you get beetles, and it typically dissipates fairly quickly.
In my opinion, maybe climate change throws all that out the window. I don't think so. Yeah, I think that both beetles and fire generally respond to a climate signal of a period of a few years of cool, wet weather followed by periods of some warm, dry years, basically. And that is exactly what we had around 2000. And what we've sort of experienced, there was a bit of a cooling in that warming trend in the late 1990s. Then things started blowing up again. We got the 2000 fire. We got some beetles now. I think that may have played itself out at this point. I think fire, I'm not convinced, and I think the science shows that there's not a good relationship between fuel structure and fire behavior on a large scale across the landscape in a manageable way. I think fuel structure makes a big difference if you're trying to save a spot from fire. That it makes perfectly good sense to protect your structures, but it doesn't make good sense to pretend you're going to affect fire intensity across a watershed by managing the trees. And I think you can, if you know the ground pre-2000 fires and you go out there now, you'll find that exactly that. There's virtually no relationship between the pre-fire stand structure or fuels management, which has been very intense in this forest for the last 30 years at least, because I've done some of it. There's virtually no relationship between how that fire behaved on the ground and those activities, and I don't think that's going to change now all of a sudden. So that leaves the third issue, which is roads. And roads are something that's not transient. They stay on the ground. They have chronic continuing problems. We know how to fix them. We could spend this money with a great deal of assurance that we know exactly what we're getting for the money. It's an acknowledged problem pretty much across the board. There's a few road segments in the East Fork that you could probably decommission and still have redundancy in the road network. You can still get around, but they're bad segments next to streams or with bad stream crossings you could pull out. There's other stream crossings that could be structurally fixed just with some re-engineering. The work that's been done to date that's supposed to be up to state-of-the-art PMP specs it's not been very well done, frankly. There's still a lot of problems. We saw them today. We saw sediment bleeding into the streams in that project area because the roads have not been well managed. So.
It's a great question. I'm glad you put me on. I'm one of the ones that was didn't give an opinion, and this is a great opportunity. I have toured this area just today and have been down in this region quite a bit in the past, and I'm very familiar with how heavily managed this region has been and what the implications of that type of management have been. My personal opinion on fuels management, and that's what this is really about, is fuels management, and is that given the approach that's being adopted here, that it's not going to stop a fire. It's simply not going to. It's not going to stop a catastrophic wildfire. It's going to happen. I've seen too many examples of it. Fires burn right through clear cuts. They don't stop at fire breaks. They don't stop at logging roads. They're certainly not going to stop when you've thinned out a certain percentage of the forest. It may drop to the forest floor if you've used fuels reduction in terms of selection harvest and prescribed fire, but simply selection harvest alone is not going to eliminate the problem. It's going up above the community zone and outside of the community zone to try and put that management into place, but you're absolutely surrounded by forest. Forest has been under significant management over the last 100 years, and as Peter's pictures clearly showed, it doesn't matter how the stand was managed previously, they burn, and they burn hot. Some of the examples that Peter gave of very hot fire were even age stands that were clearly a response to clear cutting. And those stands burn equally as hot, potentially hotter than an uneven age stand that was a product of historic fire. Fire is a natural part of the ecosystem. It influences soils in a manner that soils have been exposed to since the dawn of life. The planet is a planet of fire and water, basically, and the only unfortunate thing is that we now live in the midst of an ecosystem that's prone to fire, and we have to find a way to work with it and live with the occurrence of fire in the landscape. Does fire influence soil? Yes, as Peter's picture showed, we have certain fires that burn extremely hot and have the potential to have a long-term impact on soils, but generally soils recover very quickly from fire. There is rarely an instance of sterilization of fire. People refer to sterilization after fire frequently, but it almost never happens. I guarantee you from our work with soils and fire that there's rarely an occurrence of sterile soil. We find that even 14 days after a very hot fire, that we can have complete recovery in terms of microbial biomass in the soil after a hot fire. Now, in certain conditions where we have a lot of down woody fuel, long duration fuels on the floor, then we can have issues where it cooks out the organic matter in the soil basically, and it takes a long time for microbial processes to get reestablished under those conditions. I sat on a panel some 6 years ago in Missoula and listened to how the Rye Creek fire was going to result in jackstraw stands of lodgepole pine that were going to reburn within 5 years, guaranteed by certain individuals that were involved. And I have been to those stands, and they have not jackstrawed. And so my point is simply, it's easy to throw out figures and concepts that are not scientifically based and say, well, soil is going to be sterilized across the board. It's not going to happen. Soils will recover, they always do. Sometimes short-term, sometimes long-term. Human impacts to soils can be more severe. Urban environments, it's going to be centuries for urban environments to recover to their natural condition. But natural environments exposed to fire is not an issue. I think I've gone over my time, otherwise I'd address long items as well, but we'll leave that another time.
Well, that's quite a few opinions to follow up on. I find some of the comments interesting, but to address your question, last fall was a mixed severity fire conference held in Spokane that had probably the top 100 fire ecologists and scientists of the nation and internationally at it. And quite frankly, the proceedings are available from Washington State University. You can order them or read them yourselves. And those proceedings would disagree with all three previous comments with regard to the role of fuel in fire severity. It is extremely well documented that fuel loading drives fire. Now, I initially didn't agree with that. I thought canopy density had a lot more to do with it. But the research that's been done on the Biscuit fire and elsewhere shows that fuel loading and climate are the two predominant factors that drive fire behavior. And yes, just because you have a high fuel build or load does not mean you're going to have a very severe fire if that fuel is wet, and if when the fire burns through it, the conditions are not for a hot fire. Those are not the conditions we've had over the last 15 years. Last summer we had that condition with the rain, and who knows what the climate's going to do. If we have wet summers for the next 100 years, all the fire hazard reduction is not going to pay off, so to speak. But I kind of liken it to a friend of mine who recently was diagnosed with a severe form of leukemia. They said, if you don't treat it, you have a 10% chance of survival. If you go through the next year of horrible chemotherapy that's going to make you sick every week, you have a 60% chance of survival. You know what he's doing? He's doing the chemotherapy. So it is with fuel hazard reduction. There are no absolute yeses and nos. The condition on the Middle East Fork is such that within, not right now, but within 10 years, those big dead Douglas fir, where you have between 50 to 100 per acre, are going to break off, which is going to leave you with a fuel loading of 50 to 150 to 200 tons per acre of large diameter fuel. What we saw in 1994 and 2000 was not the fine fuels driving the fire, but it was the heavy fuels, the 100-hour, 1,000-hour fuels. And they release an order of magnitude more energy into the system than fine fuels when they burn. And the results are rather severe. And Tom, I very much respect your research, but the slides I showed were not second generation, secondary growth clear cuts. They were previously not managed areas for the most part. There was one that had been tended with fuel reduction. Please, they're my slides, they're my research. I know where they belong. You do not. So I think that's a little inappropriate. We're faced with two other things now that are out of the norm. One is, for all practical purposes, we're in a warming trend. Now, if it's global warming, it's a long-term situation. So are we going to see more of these warm, dry summers? The data indicates we are. It might be wrong. Second, we have a noxious weed issue. And as is also well documented, when you have severe surface vegetation disturbance, and soil microbial activity is not my expertise, so I don't know really what's going on there. But what we've seen over and over again is where you have the most severe fire effects, where the only plants that come back are the colonizers. Peter Stickney's work well indicated you have resprouters and colonizers, those that come in with seed. We see that noxious weeds, particularly spotted knapweed, have a significant advantage. And the literature states a tripling, and on our very research in these areas, we found that where knapweed existed, we see a tripling in cover, and where knapweed did not exist on all the plots that we put in 2001 following the fires, a remeasurement of those plots in 2003 shows that an additional 30% of plots now have knapweed on them. So, as with regard to what are the potential impacts of the proposed alternative 2 versus 3, I think from a forestry perspective, the best that we can do in forestry is to capture mortality. Not go in there and cut it while it's growing vigorously, but to capture mortality. Or capture it right before it's ready to die. That's what this plan wants to do. It captures mortality. It's leaving the best trees out there. It's reducing heavy fuels that if we have warm, dry weather, there is a strong probability that these areas will burn severely and the residual trees will die. And all the other effects with it. The plan needs to be looked at by people in the community to see if there are specific areas that need tweaking on it, but as a general concept, I think it is sound.
Okay, another question? Right here, and then we'll go right
Just
behind.
to clarify, I don't think the other scientists were necessarily saying that fuel loading wasn't a factor in terms of how fires burn in their severity. They were saying that on a landscape level, treating fuels is not an effective way to prevent large-scale wildfire in terms of fuels. And so to tie in, to make a question, I guess, out of this is, when we look at treating the fuels on the Middle East Fork project, there is a lot of commercial logging proposed. And as we know, in commercial logging, big equipment travels over the landscape. There's skidding, there's soil compaction, there's soil disturbance. Dr. Cole mentioned spotted knapweed. Well, we understand that the reason spotted knapweed is there in the first place is because of logging roads and logging activities. And I'm not sure how more logging is going to reduce spotted knapweed. But my question is, given the impacts of logging, there is, when I look at photographs like this, I look at it and fairly, I think to myself, is there a way we can get some of those trees out of there and recover some economic value but not damage the landscape? But when I see the proposal of commercial logging and the impacts there and the disruption in forest structure, the soil compaction, the soil disturbance, and the stress that is put on the trees that can further lead to bark beetle infestation, because trees that undergo these kinds of stressing for commercial logging are more susceptible to bark beetle and more susceptible to root and trunk disease. So my question is there a way that some of the fuels could be treated without causing the negative impacts that are known to be associated with logging?
Did you want to address that particular person?
Well, I guess the soils and the beetle expert would be the most qualified.
Soils and beetle.
You're absolutely right about disturbance, compaction, anything that stresses a tree. So, it's a trade-off. Maybe you reduce some moisture stress, but introduce some compaction and wounding, things like that. But, if you wound the tree or even, wound it with a tractor or dynamite or anything, that's not a guarantee that it's going to get attacked either. So but you're increasing the likelihood of that. So actually you could make the trees more susceptible if you put stress to them. And so that's a risk you take. But if that balances, the water stress relieving the water stress, it's a mixed bag. So as far as that, am I doing fuels or treating fuels? Using fire, any available ignition. In certain conditions, you could, over a series of fires, if they're not too intense to cause other problems, you could probably reduce the fuels. Remember, these old trees survived a lot of fires, and it's mixed results. Again, with beetle infestation, whether fires will make them more susceptible to beetle attack or not.
In terms of, if you could just give me a succinct question with regard to soils, you're basically asking, will these fuel, maybe you could just ask that, you know,
Well, I guess
straightforward.
The question is that a lot of commercial logging is proposed under alternative 2. What is going to be the impact on soils, forest structure, these kinds of issues on our forests?
Well, the proposal involves skyline logging, cable logging of most of the units. In terms of compaction of soils, that would be putting the true light on here. In terms of the impact of cable logging itself on soils is minimal. The impact of compaction of tractor operations there, we have a certain absolutely you have the potential for compaction of surface soils, which reduces infiltration rates, encourages runoff, and encourages erosion. Now, whether or not, if the fuel reduction treatments truly eliminated the potential for wildfire, as is being suggested, then you would eliminate the potential for having hot areas of fire that would result in complete consumption of the forest floor and exposure of those soils for erosion on steep slopes. The fact of the matter is, as was said earlier, fire is a mosaic in the landscape, and the likelihood that we're going to have all of this area burn hot like that is extremely low, and it'll be patchy in terms of the effect on exposing bare mineral soils. Any activity that exposes bare mineral soil, whether it is along skid trails or along logging roads, increases the potential for erosion and sediment loss to streams and to increase in sedimentation of rivers. So, I don't know if that, did you want to follow up?
I'd like to take a quick bite at that. I would basically just say that, yeah, there's a lot, if you focus on trees that are already dead, that you know are dead. Secondly, full suspension yarding systems from existing roads or helicopter logging. And with the caveat that basically the scientific research that's been done to actually measure fuel loads post-harvest, and this includes a wide range of forest harvest treatments in Pacific Northwest forests, and it includes harvest treatments, a bunch of them that had so-called fuels treatment as a primary concern. But if you believe the fuel causality for fire, that the fuel loads near the surface or at the surface typically increase with every kind of logging system we know. So there's a fundamental practical disagreement here about actually what effect you get on fuels from logging practices. And hand piling would be the other one, that rather than machine piling, that's another critical issue. And if you do those things, yeah, you can probably get a lot of trees off of that ground without too much impact on soils and watershed conditions.
Want to chime in?
Glad to. Again, it's not a question of reducing or preventing fire on these sites. It's preventing the type of fire on these sites. And leaving fine fuels on the site results in a fast-moving fire, low duration, low severity, typically. Leaving heavy fuels that have the propensity to dry out, and typically when a dead tree falls over, it has somewhere between 5 and 20% soil contact. The rest is fairly suspended, which leaves it a good probability of drying out. The heavier the fuels you have, the longer the duration of fire, the longer that energy is being released on a specific site of soil, the greater the probability of having severe impacts on that soil and the bare mineral soil. So in this case, reducing the heavy fuels, which is the proposal, would change the type of fire behavior to one that would be fast moving across the landscape, slower, less duration, less energy release, from one without removing those heavy fuels would be on that landscape for quite a long time. Now, with regard to logging having residual impacts on standing trees, tree physiology is one of the areas I've done a fair amount of research on. Again, you have good logging and bad logging, like with any kind of practice. If reasonable care is taken and residual trees are not dinged or anything like that, logging can have a very positive impact by giving trees more light, more water making it to the soil. With regard to the effects of thinnings and harvesting on insects, actually you have one of Montana's leading experts in the audience. Ken Gibson's been studying these effects as a Forest Service entomologist for 30 years. I guess I'd like to hear what his opinion is on what the effects of thinning and harvesting might be on beetle populations.
Well, I'd be glad to do it now.
Of course.
Try to get in a word if I could. I would like to take an opportunity to make a couple of comments, particularly relative to some of the comments that have been made, which I think are, in due respect, erroneous. There's just worlds of data to show the relationship between bark beetle, particularly Douglas fir beetle, and fire. You only have to look at the Bitterroot situation to see that in great clarity. Prior to, well, if you go back to about the 1950s, and I'm not that old, I wasn't here then, but in the 1950s we had a major bark beetle outbreak throughout western Montana, Douglas fir beetle particularly. We've had other bark beetle outbreaks since then, but Douglas fir beetle, particularly in the 1950s, was severe. From the 1950s essentially until the late 1990s, we had virtually endemic population of Douglas fir bark beetle in western Montana. Following a major disturbance event, which was blowdown, winter damage, snow breakage, ice storm damage, that sort of thing, during the winter 96, 97, we had a bark beetle outbreak, a Douglas fir beetle outbreak developed in western Montana, particularly here on the Bitterroot. Prior to 1999, we had touched around at 200-300 trees per acre infested by Douglas fir bark beetle on the Bitterroot National Forest. Following that disturbance event in 1996, 97, we started picking up increased beetle activity in 1998, 1999. 1999 aerial survey information showed about 13,000 acres infested on the Bitterroot National Forest. That typically Douglas fir beetle outbreaks don't last very long because Douglas fir beetle is not a very aggressive bark beetle compared to some of the other bark beetles like mountain pine beetle. So the population was starting to decline when the fires of 2000 occurred. Following the fires of 2000, every year since then, we've had anywhere from 30 to 40,000 acres currently infested by Douglas fir beetle on the Bitterroot National Forest. Right now in the region, we have about 100,000 acres infested. So there are just copious amounts of information to show the relationship between fire activity and bark beetle activity, and specifically Douglas fir beetle, which is always, outbreaks of the Douglas fir beetle are always triggered by a disturbance event. It's not a very aggressive bark beetle, as I mentioned. Now, one other thing I'd like to comment on, there's also reams and reams of data to show the beneficial effect of thinning in stands. We can, in fact, reduce the hazard to bark beetles by making silvicultural manipulations of stands. There is no question about that. And with all due respect to Dr. Fox, I don't know where he's been, maybe been fighting too many fires in the last 23 years. I don't know. And I don't mean that to sound derogatory. It's just that I don't think Dr. Fox has kept up on the literature because there is plenty to show that it's beneficial. No question about it. Just no question.
He was taking the bodies off the Storm King, so before you start making comments like that, let's not make derogatory comments.
There is, and I agree with you, Dr. Fox, we haven't done direct control of bark beetle population since about 1965. We did that during the first half of the 1900s, and we did realize it was kind of a foolish thing to do. But, you know, that was kind of the philosophy of the day. We thought, there was a time when we thought we killed as many bark beetles as we possibly could, that'd be a good thing. And we finally realized we couldn't kill that many. And we finally started looking at stand conditions that contributed to bark beetle outbreaks. And we do know that we can hazard-based stands. We can reduce hazard who show folks with manipulation. And there is just a lot of information shows it's very beneficial, and it can work. It just flat works. We can reduce bark beetle cause mortality significantly from in the order of 70, 80, 90% in unmanaged stands to less than 10% in managed stands. So we just have a lot of information, a lot of data that I would be glad to provide to anybody that would like to see. So that's all I have.
Okay, well, I think maybe before we switch to a different topic, I think we should give the panel a chance to respond. Does anybody want to respond?
Well, you're talking about reams of information, but I have done searches in the literature and reading a lot of this. Some of it is not peer-reviewed. I can only think of almond, which is in lodgepole pine, but I'd like to hear, just give me like 3 or 4 evidence that show directly that there is this, that are in peer-reviewed articles.
It probably is a peer-reviewed article. This observational data, it's operational work that has been done in northern Idaho and western Montana. We just have mounds of empirical data that show that it really works.
I can't use it, I can't quote it if it's not peer reviewed, you know, because that's why it becomes peer reviewed. Did they do the proper statistical tests on it? Did they do any statistical tests? Is this something that would be accepted by the community of scientists? Or is it anecdotal stories? You know, I'm good at those too. So you're saying there's reams of it, but I'm talking about, you know, in a proper peer review. There's plenty of journals out there. You know something though, the Forest Service does some good publications. Unfortunately, you know, it's not considered peer reviewed. So you have to cite that as a caveat. And often in these, in the draft, they cite things that should have, after it properly, personal communication, and that gives people a clue that this is not peer reviewed, it's just sort of a report, you know, like a police report or something like that. So once again, peer reviewed papers, I can think of almond, which is in lodgepole pine, that does show some effect, but it wasn't a great, I mean, it survived the statistics, so we have to say, yes, there's a significant difference. But as I recall, it ended up being like a half a tree difference per acre or something like that. But beyond almond, I can't think of any. Can you?
Almond, lodgepole, this gentleman right here to my right, very bottom doctor, has some published reports showing the effects of thinning in lodgepole pine. Again, it's lodgepole pine, but we have an awful lot of published data. Mark McGregor has several articles. I've got a published article on thinning in lodgepole pine. Again, I will certainly readily admit that a lot of published data is in lodgepole pine, but we've taken those principles and applied them to other bark beetle species and their host, and almost without fail, the principles are the same and they work. Operationally, they work.
Okay, I think we should move on. The gentleman who had his hand up first, and then maybe we'll
Yes,
go back and forth.
I'd like Dr. DeLuca? Can you describe the kind of soils in the project area, the decomposed granite or weathered residual soils? And given the kind of soils that's in the project area, what percent of the nutrient exchange do you believe is in the humus layer? And how would that affect when you lose not only the litter layer, but the humus layer in these hot fires? What does that do to forest productivity? And then the second part of my question is, given the kind of soils that are in the project area, do you have some documented measurements of soil compaction there?
The question on the soils in the project area, they're primarily decomposed or decomposing. Granite would be the parent material that the soils are formed in, and so they are primarily sandy loam soils. They have they're generally minimal development in terms of their what we call insectisols for the most part. They're but they have surprisingly high water holding capacity for a sandy soil because of the nature of how granite degrades. The way granite weathers compared to something like limestone, which fractures with depth and has macro porosity that allows for channelized flow of water during saturated flow periods. Something like this granite holds a surprising amount of water in depth for as sandy a soil is. So if you look at surface soils, you may say, oh boy, it's low water holding capacity, but they end up being fairly productive soils because of water holding capacity and depth. The soils have the finest texture would be in the surface, probably surface 20 centimeters of soil, which would be, as I said, sandy loam, so it's a mix of something on the order of 15% clay, 10 or maybe it's hard to say, 30% silt, and the rest would be sand. So they are definitely dominated by sand. I'll come back to that later then when we talk about compaction and the potential for compaction in these soils. The question was where is the nutrient content dominated, or what's the nutrient content of the humus layer versus the litter layer versus the mineral soil? And the answer to that is that particularly with nitrogen, which is the primary nutrient, mineral nutrient required in the largest concentrations by trees in our forests, is concentrated in the surface mineral soil and the humus layer. That's because nitrogen does not exist in the parent material. It is not a part of the granite. It's introduced into the soil by years and years of nitrogen fixation and by biological nitrogen fixation, and then accumulated in organic material over time. If we were to say, what's the concentration of nitrogen within the humus layer versus within the mineral soil, you might at first say, well, okay, the concentration of nitrogen in the humus layer is on the order of about 0.1% nitrogen. It's quite high. But the humus layer is low bulk density, and it's a relatively thin layer in these soils. If you go look at these soils, it's a relatively thin layer. And the majority of the nitrogen is actually in the mineral soil, surprisingly, in spite of the fact that that humus layer has a higher concentration per unit mass. The amount of nitrogen contained in the mineral soil is actually higher. That said, the humus layer is an incredibly valuable reservoir of water holding capacity, nitrogen, a reservoir of nitrogen, reservoir of cation exchange capacity, etc. What happens when we have a fire and we lose that? We lose a valuable resource. We lose protection from raindrop impact when we lose the litter layer and the humus layer, and we expose the soils to erosion. If we lose that humus layer, we lose nitrogen content, we lose other nutrients as well, organic phosphorus content, and etc. Let's see. In terms of does that answer that question sufficiently, or did you want me to give more in terms of nutrient content? The majority of the base cation concentration retained in the soil, potassium, calcium, magnesium, that's held within the mineral soil. Absolutely, no question. It is there is some concentration of that in the humus layer, but the majority of those nutrients are held and taken up from the mineral soil in these forest ecosystems. When we go to other forest ecosystems, boreal with the thick forest floor and the thick humus layer, then we have more nutrient uptake from the humus layer. But in these systems, the majority takes place in the mineral soil.
So there isn't really a significant loss in productivity when you lose the humus in the soil? Is that what you're saying?
No, that's not what I'm saying. I'm saying that in terms of the nutrient capital of these systems, the majority of it is definitely held within the mineral soil.
Talk about availability for exchange and plant.
The majority is taken up from the mineral soil, from these systems. That's not to discount the humus layer. It's valuable. It's absolutely valuable. It protects the soil from raindrop impact. It creates water holding capacity. It is a reservoir of nutrients. It's a zone of high microbial activity in the humus layer. Okay? So I'm not discounting, I'm just saying the majority, your question was where is the majority of nutrient content? And it is absolutely in the mineral soil. And I'm not saying it's going to but we can have a fire and lose all that, and we don't lose anything. We absolutely do. We lose protection, we lose a reservoir, and we lose water holding capacity.
Relatively small amount of exchange.
Yeah, relatively small in the big picture.
About the compaction.
Compaction. These soils, though sandy, are still aggregated. And if you pull up the soil, and I encourage you all to do this, I mean, soil's a beautiful thing. There's a reason why kids love to play in soil, because I looked for a job in soil because I never got enough of playing in the dirt when I was a kid. But you go out and you take a handful of the soil, and you look at it, and it's all aggregated. It is high in sand content, but you look at that surface soil, and there's particles of sand, silt, and clay all glued together, weakly glued together in these high sandy soils. So what's it glued together by? It's glued together by fungal hypha. It's glued together by microbial saccharides. It's glued together by clays. Clays tend to be very sticky. It's incredibly small, high surface area. They stick together in these secondary particles we call aggregates. And you look at this soil, and these aggregates all sit connected to one another loosely, and this creates a seed bed through which roots can penetrate readily, water infiltrates readily, okay? And even though these soils are sandy, you can compact these surface soils. The concept that these soils are sandy, mineral soils that are resilient, or I don't want to say resilient, I'll say resistant to compaction is false. These soils can be compacted. Now, that said, they're not going to be compacted like you'd have with a high clay soil. High clay soils, such as we have in pockets throughout western Montana, when they're wet and you get on top of them, you destroy the structure. And it's going to be decades before it's recovered. In these sandy soils, it will recover more readily because of freeze-thaw activity and root activity can break up, move those particles apart from one another. But you certainly can compact these soils. They're just more resilient to compaction than other types of soils. But does that answer the question?
I asked if we have measured compaction in the project area.
I have not measured compaction specifically in the project area. We measure compaction on terrace soils up above the Painted Rocks Reservoir. We've measured, which I think those were more dominated by belt, actually, where we were working. Yeah, so I haven't specifically measured compaction in the project area.
Okay. I would like to ask a question about thinning. Thinning, there's two procedures that have been recommended that I've heard, mechanical and thinning by burning. And thinning by burning, you destroy your old growth. It's non-selective. Thinning mechanically, you can end up with a variety of species, sizes, ages, and so forth. The other thing, by thinning, you have the capability of taking the material that's removed, and what do you do with it? You may have as many as 400 to 500 tons per day, which is what happened in San Bernardino when they did the removal of the prior component material there. And Senator Feinstein requested that a gas-fired incinerator be used to dispose of the fuel. And to me, this is a tremendous waste of a natural resource, natural gas, to burn another fuel. And now this fuel could be broken down into a wide variety of things, because if you're doing a true thinning, you're going to be taking what is left is a variety of sizes, ages, species, and so forth, to break the crown. You don't want to have all old trees, just like we don't like all old folks. We like to have kids coming up. And so we want to have something for the future. And so what we need to do now with the fuel is break it down into usable material that is marketable so that you can finance the thinning operation. And also, if you do the thinning, then you don't have to fight the fires when it burns up by a forest fire. So the different kinds of materials can, the decent sized trees, the larger trees can go to the mill. The smaller ones can be used for a variety of things. And the fuel itself can be used for generating electricity and using the heat for manufacturing. It makes sense. We cannot finance forest fires forever, but taxpayer expense. We have to look at the material we're taking out, what we're going to do with it.
Anybody want to make a comment, response?
I'll respond to that. I would say don't sell your fire trucks just because you thin your forest, because there's going to be fires. Thinning does not stop wildfires from happening. And thinning, there are possible benefits to thinning in many circumstances. There are also impacts associated with it that we need to take into account. I'm not saying thinning is always bad, but I would definitely tell you not to sell the fire trucks. So.
Well, I'll quote something that Jim Agee, who's recognized as probably one of the leading fire behavior experts in the world at the University of Washington. I mentioned about thinning with fire or thinning mechanically. If you thin with fire, basically the idea is you run a surface fire through a stand to kill the excess smaller diameter trees. Within 10 years, you need to reburn that, because within 10 years, the fire-killed trees fall down and again create actually a worse scenario. So if you rely on thinning with fire only, without having a fire run through there again, approximately 10 years later when that material is down and consumable, you may potentially have a worse fire scenario. Mechanically thinning, you're removing a lot of that material off-site. There is some question about nutrient cycling with small diameter branches, twigs, and things like that. There are some questions about how it's done and the impact to the soil by mechanical equipment. Logging practices have come a long ways with low impact types of logging equipment as well. So there's pros and cons on both. In this proposed study area, or proposed treatment area, it's a lot of large diameter stuff that's dead in there. And so much of it is quite merchantable. I believe, and I have to refer to the Forest Service people here, but I heard numbers like 15 million board feet coming off of that, which represents enormous wealth to the economy to have something like that come on. And again, these are dead and dying trees. So.
Something I've been hearing a lot about interspersed with fuels management is the idea of restoration. And I think we have to realize that in many cases, what's being discussed are two different things. Restoration is taking back a forest to what we can, and some of the things that are being planned could be considered or have been called restoration, but I'm not totally convinced that's the case. If you listen, it sounds like we're trying to make all fires exactly the same. We want them to be very cool. We want them to always burn the same. Stands should all be treated the same. And that's not the case. That's not the way our forests have evolved. And that's not the way that forest health is going to be maintained. These forests are incredibly complex. Fire is an integral part. Bark beetles are an integral part. And if we try to stop all of this, thin everything to beetle-proof, to stop all fires or stop them from being, or making all fires exactly the same, we're going right back to some of the things, the mindset that's got us in this place to begin with. I agree with Ken that in many cases thinning can manage bark beetles. I don't agree that you can extrapolate what you've learned perhaps in one pine species to some other tree. I think that each bark beetle behaves very, very differently. They're very complex and we have a lot to learn about them. And they behave very differently in different species of trees, even the same beetle in different species of tree. We're also faced with something, by the way, I'm an entomologist, in case you wonder why I'm up here spouting about this. I'm also at the University of Montana. If we're really concerned about fuels management, there are certain approaches I think you can take. I'm not the person to talk to that. But if you're concerned about restoration, and I was out at the site today, and it's a bunch of clear cuts and terracing and a few remnant fragments that now are going to be managed. I think you have to look back at what it was that nature did to maintain those ecosystems, and then go and look at that. And if what you're looking at is trying to stop that and alter it, then maybe that is just as bad as some of the other management practices in the past that have gotten us here. We have to go back and look at what it is that keeps that forest natural and maintain its kind of flow in order to manage it. And I don't think that all the things that have been brought up today really There's this other thing about going out and treating this big area. And like Peter said, well, if you do this, then you've got to go in and you've got to maintain this. You've got to burn it over and over. If you do this thing by burning. Well, what about this kind of a treatment? This is not the kind of treatment you can walk in and do and walk away and not maintain over the long term. Okay? You can't just treat something and expect the forest to stay that way forever. You're going to have undergrowth come back in, you're going to have dug fir come back in, and the whole thing's going to repeat if you don't do something to maintain it. It's a short-term kind of approach. So you have to think about what it is that's going to need to be maintained, and if there's a commitment behind it by the Forest Service to maintain this, burning or whatever. Okay, because the treatment, one-time treatment alone isn't.
Did you want to direct a question to one of these guys?
Oh, no, I'm sorry. I was trying to address Ken way back when.
Okay, that's fine.
And I think I got off track because that isn't even a question.
That's okay. This is about public dialogue. Yes.
I was wondering if it's appropriate. I know the panels have come a long way, but can we ask questions from the first two presenters about alternative 2 and alternative 3, or should we wait on that?
I think you should ask what's ever on your mind. That's why we're here tonight.
Okay. I was curious, from what I've read of the draft, it doesn't seem, well, what I can find, there's nothing in there about road restoration, but I think everyone agrees that roads are a big problem with sedimentation, and if it is the healthy forest restoration, why isn't the Forest Service as part of this? And I'm not totally convinced that we shouldn't take a fair amount of trees, but why isn't the Forest Service addressing the road issue?
In both alternative 2 and alternative 3, the projected treatments may actually add some sedimentation through modeling of what happens if you burn an area, possible to increase the sedimentation to the streams. And with mechanical treatments, there's a possibility to increase sedimentation. And both alternatives have road restoration work that would minimize the sediment to offset any potential increase due to management. So there is some work identified in both alternatives that would mitigate any projected increases in sediment. Okay, if you're looking like you're not sure.
No.
Okay. There was a decision made for 4 reasons actually to focus the Middle East Fork Hazardous Fuel Reduction Project on vegetative treatments. One reason is because we want to make sure that anything that we identify in this draft environmental impact statement or the final environmental impact statement can actually be accomplished. We want to make sure that something that the measures I've identified there will actually be done. Secondly, there is a backlog of road restoration work on the Bitterroot National Forest that still is pending to be completed. So those projects need appropriated dollars to be accomplished as they would need to be appropriated dollars for the Middle East Fork project. So we don't want to put a bunch of projects in the document that we weren't comfortable that we could complete in a reasonable period of time. The third reason was, again, this is a Healthy Forest Restoration Act project, which has some special authorities. It helps streamline the project to reduce fuels in an expedited manner, and it says that appropriate tools should be used to do Healthy Forest Restoration Act projects, and those tools are identified as vegetative management. Those are just the types of tools that are identified as vegetation. It doesn't mean that there isn't the need or the ability to do other road restoration work in the Middle East Fork area. It can be done under a different planning process, but the decision was made to focus this on vegetative fuel reduction. There is some road work, but that's just to offset potential sedimentation that could occur by both alternatives and actions. And then I'm going to ask if, because if there's anybody else that would like to add to that from the Forest Service, I'd like to offer that. Okay. Or correct anything that I said.
Done. All right. Anyone want to respond to this? Okay. Hands again. Let me see who was up. Yes, sir.
Well, Larry wanted to say something about night.
All right, we'll go here, and then Larry will go right after. Is that all right? Or respond to that?
No, I haven't.
Actually, could I add one other thing to that? If I
Sure,
could?
sure. And yes, I should have given Larry a chance if he wanted to have added something. I apologize.
I did want to say that the coalition that presented alternative 3 made it very clear to the Forest Service that they were not happy when they found out before the draft environmental impact statement was released that element wasn't included in the alternative. And so in the draft environmental impact statement, we did add, through a discussion and dialogue with that coalition, a list of road restoration opportunities that were identified through the watershed ecosystem assessment that we did that are there, and the cost of that is in Chapter 2, I believe, of the environmental assessment, explaining that was something that the coalition would like to have had, and explain why that's not included in this specific hazardous fuel reduction project.
Can I just give Larry a chance as the other presenter? Do you want to say something now before we move on, please?
Well, I guess, yeah, our reading of the Healthy Forest Restoration Act, we don't find any prohibition of road restoration in there. And you know, I'll just reiterate that we believe that road restoration is one of the most important restoration activities for aiming at a healthy forest. We need to do something about the road, and to spend, you know, this $1.5 million of appropriated funds and choose not to take a look at road restoration aside from the restoration that mitigates the logging, in my view, is just it's a wrong priority. I think the priority should be for healthy forests to address the problems that are on the landscape right now through the roads.
Okay. Sir.
Well, I've heard things that kind of go against what I've learned in the last 40 some odd years in the woods. And the idea that this alternative 2 is going to create a lot of damage, I think we really have to look at that hard. Is the risk of damaging the forest much greater for doing alternative 2 than not doing alternative 2? Certainly the reduction in fuels and the reduction in resistance to control, having less resistance to control after the treatment, will enable the firefighters to put the fire out quicker and easier and cheaper in the long run, and save money in the long run. There's a couple of things that just stuck with me long. The idea that these treatments that were done 30, 40 years ago did not do anything to help to stop the fires that burned in 2000 is wrong. Just look at the pictures. They burned up to the clear cuts and stopped. And those aren't just bare ground, those are trees there. The idea that these regenerated stands are dangerous to a firefighter, I don't know where that came from. But the idea that reducing the fuels isn't going to slow the fire down is absurd. Look at in nature, what happened. The fires came every 10 years, 20 years, whatever they are, and they cleaned up the fuels. And therefore, the big trees could continue until something happened to them and they fell down, or someone got severely burned because of some reason. That's what nature did. This idea of alternative 2 is trying to emulate nature. It's trying to take out the big trees where they need to be taken out. Not just help the skeleton where they are decayed or damaged or diseased will be taken out. The Douglas fir will be reduced in numbers to favor the pine, which is more fire resistant. It's a plan, and it's not. The idea that fuel management is not going to do anything, I think it's absurd.
Would someone like to respond?
Well, first off, I don't think anybody's saying, for a couple of things, I didn't say that there was absolutely no evidence that stand manipulation can do anything about insects. I was saying the evidence is mixed. You know, it's just you have one report saying this and another report saying that. It's still, the jury's out about it. And I think this is what we're saying as well, that in some conditions, you know, it can be helpful. Certain moisture levels of the fuel, you know, that's going to be a determinative thing. So, you know, we're not saying that in every case this doesn't work. In some cases it can. We're saying, look, if you take a big picture, it's a mixed bag. It's a mosaic out there. Sometimes it works, sometimes it doesn't. So what's the best use of our limited funds? I mean, why shoot all your money on something like this when you just don't have a great certainty that this is going to be that beneficial?
Well, a couple of quick things on this. With the idea of restoration and thinnings and what the proposed alternative 2 versus alternative 3 does, when we talk about forest restoration, there are many definitions of that. One is to restore it to the historical realm of variability. As an ecologist that deals from the micro level all the way up to the macro level, I guess I would define restoration as making these forests more resilient to current disturbances and projected disturbances. And projected disturbances, quite frankly, scare the heck out of me. Now, it's no fluke of nature that our forests historically were very diverse, structurally and species-wise. It's because our climate here has always been diverse, our topography is diverse, our soils are diverse. And when you have constantly changing climates, which means different moisture regimes, different drought levels, different disturbances that come with those drought levels like fires, an ecosystem as a whole is most resilient when you have multiple age classes and multiple species. Because what may affect one age group and one species will not affect as strongly another age. They all have different physiological abilities to withstand those stresses. In this proposed project, leaving those legacy trees that have survived the Douglas-fir beetle attack, that have survived 300 to 500 years of climatic fluctuation, and protecting those, to me as an ecologist, is paramount. Now, okay? And then on top of that, they're proposing to treat 6,000 acres out of 30,000 similar acres that are affected by Douglas-fir beetle. It's not affecting the entire landscape. It's not taking the entire Bitterroot National Forest, or even the entire portion of the Bitterroot National Forest that is this old Doug fir ponderosa pine mixture, and turning it into something different. It's proposing to treat 6,000 acres out of 30,000 acres that looks like that. So, you know, it's not trying to change the world. It's trying to impact a small area. And yeah, it is a little bit of an experiment. Everything we do in nature is an experiment because we can't be certain about anything out there. But the probabilities indicate that there's a high chance of success of protecting these big old trees, reducing the effects of some of these fires that we've seen in the past, not taking fire off the landscape, and it's on a small fraction of the entire landscape.
I would, just to respond to that point, that it's a small fraction of the landscape, what proportion of the budget of the Bitterroot National Forest is it taking to manage this small portion of the landscape in the next however many years it takes? Indefinitely. That's not what it takes. Do we know that number? I mean, how much of the budget's already gone to planning, and how much, you know, what proportion of the Bitterroot Forest budget does this project represent? Is that the place to be and the way to be spending that money? That's where I come at this question.
Do you want to respond?
Well, I'm Tracy Holmstead, for anybody who doesn't know me. I'm the district ranger in Sula. And I don't know the answer to that. I don't know the exact number. But I guess, you know, what I'd like to mention is that this project stemmed from what the community, the Bitterroot Community Fire Plan talked about. And it emphasized this area as high priority for treatment. So there was public involvement in focusing some attention in this area.
If I could, I just wanted to follow up, because I thought that was a really good question. And I think that there was a misconception, perhaps, that when for example, I said that if you go and you manage this 6,000 acres, or, you know, the small amount of forest within this large area, you're not going to stop the fire. If a fire is moving through this landscape, you may save some of these relic trees, And that's wonderful, and I applaud that. But you're not protecting the community by creating a patch out in the middle of the woods that you're protecting. And that was my point. You're not protecting the community. It's the area, it's the management closer to the community that's protecting the community. And there seems to be there's misinformation that's being presented suggesting to you that, number one, when you say restoration, and then you back it up by saying, well, when I say restoration, I mean projecting towards creating a healthier forest. That's not restoration. What is restoration? It's exactly what Diana said. You're trying to restore to a community that we think used to exist on that landscape. And that's fine. That's fine, but that may be based on flawed logic. We may not know what that landscape really looked like historically, and we may be managing it improperly. But the point is that is 6,000 acres in the midst of 30,000 acres, and the fire's going to burn right around that area. And it's going to spot, like Peter just said a moment ago, if it's hot and it's windy, that's not stopping the fire from burning towards the community. That's all there's.
Julie.
I don't know that I actually have a question, maybe a question, but I just wanted to kind of follow up. Everybody keeps saying that this isn't going to stop the fire. It's not going to stop the fire. That's not what the Healthy Forest Restoration Act even says.
That's
Healthy Forest Restoration Act says that you're trying to change condition class. And I'd be happy to read the bottom of it, but I'm not going to take the time. I mean, the reason the Healthy Forest Restoration Act came up was because of the fire condition, because of the Western Governor's 10-year strategy, because of other analysis that are out there. And so even to have a project like this under this prescription, the community had to go through a process of identifying fire regimes and condition classes that they needed to change. So that's why we're even talking about this. It's not going to stop the fire, but that's not the purpose of this prescription. So I just want to clear that up.
That's great. And I appreciate that, because that's being mixed with, people are taking that and mixing it with the Healthy Forest Initiative with community protection and stopping the fire.
No.
Modifying fire behavior.
We're trying to change.
I know, but I'm saying people
class.
are mixing those two.
Well, maybe you're mixing it, but I don't know that a lot of people in the audience are mixing it.
No, I don't mean the people. I've heard it stated several times.
Okay, well, I
by some
had two
individual.
other comments. As far as the costs between the two, alternative 2 and 3, what has been totally missed is that in alternative 2, you have millions of dollars, over $7 million, going to come back to the local community, where you do not have that in alternative 3. That's not even being addressed when you talk about the difference between the $500,000 and the 1.3 or whatever. But I also
who's
like
that going to?
It's going to your roads, it's going to your schools, it's going to your people that.
It's going to the logging industry.
No, it's not. It's not, I'm sorry.
It is not.
And we can argue that later.
Let's let her finish, and then I'll give you a chance if somebody else wants to respond.
I just want to know where the $7 million is going.
All right, I'll put you in touch with Chuck Keegan, and he can talk to you about the analysis that they just did on what logging activities do to the local communities. It's not going, no, you think the loggers are wealthy people? No. I mean, we can talk about it later. That's not why I stood up. And also, obviously, I represent the Montana Logging Association. I would encourage anybody that has a question or concern or an interest in joining us on an active logging site. We do have foresters in the audience. We have some great poster childs of logging activities all over the West. I'd be happy if you want to call me. I will hook you up with somebody, and you can go out and take a look at what we actually do. And please do not hold the 600 independent loggers in Montana, hold them to what happened to the sins of our fathers back 30 years ago. I mean, we have a different generation of logger out there. We have a different generation of equipment. We know more now. Montana does a great job with their BMPs. So I just would appreciate that before you start criticizing what we do, come and join us.
Before we shift to a different topic, does somebody want to respond to this topic?
Yes, I would.
Okay.
So there's a $7 million generated. I'd like to know if there's been any economic analysis. If this alternative 3 was applied to the Middle East Fork and 2 other similar communities, how much money in terms of homes and lives and other community values might be saved by going with alternative 3? Is that in the DEIS? Have they done that economic analysis?
You're asking the wrong person.
Would someone from the Forest Service like to respond?
No, we haven't included that as part of the economic
that
analysis,
would
but I
just-
would add one thing, Larry. You, there's been a lot of talk about the $1.5 million that this alternative 2 would cost, and the $500,000 that alternative 3 would cost. And there's been no mention of the 289 jobs that the economic analysis talks about in alternative 2, and the 21 jobs in alternative 3, or the $7.5 million income that is part of the economic
That's what I was
analysis
just
for
responding to.
alternative 2, and the $0.4 million in alternative 3.
Well, that's
Those
what
are
I was
all-
just responding to.
Those were all part of the economic analysis, and I just, it's frustrating for me to hear just one piece of it, so.
Well, it's frustrating.
But you never did the
Wait,
studies for our
guys, we
alternative.
can't talk over each other. Do one of you want to respond to this, and then we'll finish this up and move on? Do you want to make a comment, sir? Do you want, you can go ahead if you want.
It's a one-sided show here. They've never done the economic analysis on our community and local economy alternative. They've just examined the logging alternative.
Well, in the EIS, those alternatives 2 and 3 have the exact same criteria, and it's looked at the same way.
On this point, someone want to speak to, on this
We
point?
don't believe that our economic alternative is only going to generate $400,000.
Okay, how about here in the
Well, the returns that come from timber harvest are the returns to the government. That's saving the taxpayers. There's going to be a $6 million profit on alternative 2. Absolutely, that's what the analysis shows.
Oh, man, it's sand through the hands.
That's
If
to
you think it's a profit
that's just to
to
the
the
government.
U.S. taxpayer.
That's just to the government. Then you have the economic benefit of all the jobs, of all the truck drivers, of all the loggers, of all the mill workers, that material going into the economy is going to generate. And so the benefits from alternative 2 are much more than those direct returns to the government.
The shelter.
I'd like to
skip some of the terms. Yeah, please.
I think we're finally getting down to what this project is really about. This whole thing has been cloaked in the language of healthy forests and stopping insects and so on and so forth. But really what a lot of this comes down to is, again, a large old-growth timber sale that provides some jobs, provides some money. But this project will lose $1.5 million after the revenue.
Let me finish, and then we'll.
It will lose $1.5 million after the revenue come in from the logging receipts. It costs $3 million, it brings in $1.5 million. That's the bottom line figures for this. If you want to look at further economic analysis, what is the damage from the long-term damage from the roads out there? There's a $10 billion backlog on the Forest Service lands because of roads. And if you want to go down the line, continue taking into account all of the economic benefits, take into account all of the economic losses that accompany these things. The real thing that we're dealing with here is again, a timber sale. And I think on top of that, the trend has been to state in black and white terms, as Ken Gibson did, that we can do something about this beetle epidemic. Why was none of that in the DIS? We looked at every citation you had in there. One was peer reviewed. None of them showed what you said. They were trip reports. They were unreviewed documents. We're not being honest about the potential negative impacts of these things and the very uncertain benefits of these things. You've got a stand out there that has a huge reservoir of insects. It has huge populations of insects out there right now. The climate is warm. We're in the middle of a drought. We've got trees that are a susceptible age for this. A lot of the thinning work that has been studied in the past has been in confined areas. It has been, some of it preventative, right? Yes, most of it is preventative. We're not talking about a preventative case right now. We're talking about a case where
in the face of an outbreak. They did work time and time again.
where's the research? It's not in the DEIS.
I'm not talking about research, I'm talking about operational things that work.
But where's the proof that they work? You talk in unequivocal terms about these
All
things
over
working.
Western Montana, if you want to go.
Okay, we
I wanna
have a
see some-
disagreement over here.
What I want to see, I'll wrap my point up, is I want to see some evidence that it works in a consistent fashion as you state, and that evidence is not there. As Joe Fox stated very clearly, there is mixed evidence on this point. You're not being honest about that with the public.
I've been doing this for 30 years, how long have you been doing it?
How long has the science been saying this? The science does not say it.
30 years.
Okay, guys, I'm going to cut this off. Obviously, there's a disagreement here on the topic, the background, the science. Yes, sir.
You've got a disagreement
with knowledge and science against opinion. I mean, I think we should listen to.
Which one's which?
And opinion is,
Okay.
it's just a difference in opinion.
I need to give people,
Is over here.
guys, I need to give people who haven't had a chance to speak a chance now. So I'd like for someone who hasn't had a chance yet, down through in the back.
Dr. DeLuca, 2 questions regarding the community and regarding soil compaction. In the community, do you consider the trees part of the community? I personally favor, I like the trees more than the houses, to be real honest with you. I mean, could they be considered part of the community, particularly the larger old growth trees, which I personally favor. The second question is, given the fact that if I waddle across the ground in my hot cell, it's going to compact the soil.
Waddle across the ground.
If I drive across the ground on a ground-based equipment logging, okay, and it compacts the soil, are there any reasonable mitigation measures that can be taken to restore that? Thank you.
Yeah. First question with regard to the trees, are they part of the community? And the answer is absolutely, they're part of the community. But that's not what I was referring to when I said that if you go and if you're trying to protect the community, and when it comes to fighting fire, when it comes to putting money and effort into fighting fires, it ends up being all about protecting property and not about protecting resources. The bottom line is the money that's spent is spent to protect property, and that would be homes, right or wrong. And I think those trees should be protected, but I don't necessarily think that. I think that there is the chance that with the right type of operation, thinning and prescribed fire, the fires would drop to the ground and they would not harm those old legacy ponderosa pine that were in those stands. On the other hand, another piece of misinformation that seems to be being put out is that these trees that are standing, that are dead, are going to fall to the ground and create a catastrophic fire. I've heard that so many times, not just tonight, but frequently in discussions. And how come when you go out into these forests, you see these snags well after they've been dead for a long time, they're still standing? It's not next year that they're going to fall. It's going to be when there's an intense windstorm, or there's ice storm, or there's something that's going to take some of these down. And by the time they go down, right now, we're out looking at a number of these trees today that are dead, and they're already rotting. They're rotting while they're standing. And to say that it's going to take them 150 years to begin to rot is ludicrous. They're going to rot when they hit the ground. They're already rotting right now, and they're not going to be in a condition that's going to contribute to fire in about 15 years. That's just a general statement. And as long as it's on moist slopes. Now there's dry, exposed slopes that they would stick around a lot longer for. But that's just a statement that's been made multiple times in the past as well as even tonight. And I think that's a piece of misinformation.
So what you're saying is that the trees are part of the community, but they get kind of pushed off to the side and we get to worry about the people. Okay.
No. I'm just saying that when the Forest Service puts money into fighting fires, it's about protecting property. It's not about protecting trees.
Right. But they are part of the community.
Absolutely.
Okay. And about the compaction, is there any reasonable mitigation to it after we do a ground-based system?
My personal opinion is that if the ground-based operation has been done right, it's best to just leave it alone and not go in and attempt mitigation activities, which can be more disruptive than the activity in the first place. I can think of some examples in the neighborhood where mitigation activities were put in after the harvest. There was minimal impact to the harvest, and the erosion control structures that were put in afterwards are the hot spots of knapweed on the landscape, and there are mounds of soil that you can see erosion occurring on.
Kelly, how much you're referring to?
Yeah. Use of tool like a subsoiler or something to break up compaction of these sandy soils is a waste of your time and effort. I think that better spent allowing freeze-thaw activity and root activity of a healthy understory to repair that damage than to go in and actually rip up that surface, because you're going to expose mineral soil and you're going to actually increase the potential for erosion under those conditions than you will by leaving it intact.
So a mitigation measure would be limiting passes, using
I
a low ground pressure type machine.
Yeah, and using a designated skid trail, not a non-designated skid trail, because it minimizes the amount of disturbance on the landscape. And each successive pass has very minimal impact, additional impact to the soil. The majority of the compaction takes place in the first 1 or 2 passes of the equipment. And after that, it's a minimal impact. It's a logarithmic response. It tails off.
Did you want to make a quick comment, because we're going to be ending in a few minutes, and I want to make sure a few more people get there.
Yeah, well, I've been repeatedly attacked by some of the things I've said, and I need to reply to those things. Number one, there are numerous studies out there that look at decomposition rates of different species under different conditions. And actually, Lubbock's Forest has a 24-year-old demonstration where material was thinned with various treatments, burning, piling, etc. It's now year 24. You go out to the material where it was piled or where it was dropped and left, and it is still, according to Mick Harrington, fuel specialist at the Fire Research Lab, extremely high fuel, extremely flammable, and any of the aerially suspended stuff is 90% still intact after 24 years. And this is small diameter ponderosa pine. That's a high percentage of sapwood, and is that type of wood that decomposes the most easily. There are also numerous studies out there that substantiate that this material stays intact for often hundreds of years out there. Now, on this particular site, as I mentioned on the field trip, I would expect it to remain a fuel for up to 100 years on that site, and that's based directly from a discussion I had with Mick Harrington following the fires of 2000, visiting sites where fire went through, stands where that large diameter material exactly was. So these are not unfounded comments. They're based on a lot of research and a lot of different backgrounds. So they decompose at different rates, and even the punky logs that didn't burn, Mick still considered as fuel. So now with regard to soil compaction, just draw a little bit of a parallel on there. For one, I was just out on a logging site this afternoon, Craig Thomas's, similar types of soils, where he had made numerous passes with his forwarder, and I was sinking ankle deep into that soil. So, you know, it wasn't really a compacted issue. And the parallel is compaction was really studied in agricultural systems. And when you consider on farmland, you have tractor equipment running over no-till soil year after year after year after year. Now, there are compaction issues. Here we're talking about a few passes of equipment, so just keep that in mind.
Okay, you had a question?
Yeah, I just wanted to add something that was relevant to the discussion over here. We're talking about three, we're talking about, you know, whether the economic agreement and not having houses burned down and things like that. And I just want to point out that Dr. Greg Jumpsworth from the Economic Research Station in Missoula is upon this and doing that type of research, looking at the economics of no action. And, you know, what is that potential cost in the future? And also he does economics research on suppression costs, things like that, just to let you know. I don't know if anything's been published yet. And then also that brings up something that I wanted to address earlier. There was a comment made that Forest Service scientists do not publish in peer-reviewed journals, and that is not true. They publish in peer-reviewed journals all the time. I'm personally a co-author with Forest Service scientists on peer-reviewed journal articles. But if the comment was referring to Forest Service publications that are separate and different from peer-reviewed journal articles, those do also have a peer-reviewed process, but it's different than that. So just to make that, clarify that point and speak to the merit of Forest Service research.
Okay, I'm getting signals that it's time to end this. I think the fact that you guys have stayed for almost 3 hours suggests the intensity of everyone's involvement in this topic. Thank you again. I hope you got some questions. There's no resolution, but I hope you got some information. That's what the purpose of tonight was. Thank you for coming.
And do you like it?
Thank you so much.
And they got a significant difference, but just barely common sense. And it was something like half a tree per acre, you know. All the sound and area for that. So, but that's the one thing. That's what it shows. And, you know,
And on a site-specific basis, when you look at the overall epidemic, as they're calling it, it just seems like we're powerless to do anything about that. It's like a flood or a hurricane. It's a natural occurrence.
And when you catch them on that, the chameleons go, well, let's recover the economic value.
Yeah, right.
They're just switch all the time. They're like sleeping sickness. You know, it's the whole microbe that shit. You know, when it gets attacked by antibodies, it just rips out of its old skin and has a new one. You know.
Yeah. And somehow logging always seems to be the solution. It always is in there the solution.
They say August. We had 60 people out here, the East Fork people saying that all the community members could be here. Oh, yeah. Cameron was with them. Well, we will warm up as we go all the way back up to the road.
Yeah, and they appreciate the legal,
I guess we should
impose on the judges too for restraining orders or
injunctions have to happen much more quickly and have to be